So I want to talk about an interesting preprint publication that just was published. And this is the title is Converge or Collide, Making Sense of a Plethora of Open Data Standards. It's an editorial, and the authors are, they are pretty impressive in their own right. And we've had two of them, both Rachel Dunscombe and Graham Grieve, on the Digital Health Hackers podcast before as well. And Rachel Dunscombe is the CEO of openEHR, Graham Grieve, the founder of FHIR. And there are other people involved here who are from OMOP, and they have given a big list of all the people involved. So you have a guy from OHDSI, which is the OHDSI and FHIR OMOP collaborating working group. So these are all big names in their own right. And this paper goes into what's the status of healthcare data standards today. And it's a very honest kind of a paper, and it doesn't seem to, like, it does not come up with a dogma and say, like, use this for that. It's more of a, we've noticed that this works best for this particular use case, and they've broken down the whole healthcare enterprise into multiple use cases. So I just thought it would be interesting to go through these different use cases with you, and just break this paper down and comment on what their findings have been and how this relates to my experience as well. So the first key thing that they do is they break down the healthcare data domain into three distinct domains. So first they have clinical care and administration, which is like primary data capture, documentation, and uh, data needed for continuity of care, billing, insurance claims, all of this. So this is the primary data that you store in, let's say, an EMR or an EHR, so that you can just do your regular business logic, right? So this almost every hospital needs this. They either have it as paper records, or they somehow have this in some place. So uh, the next concern is data exchange. So now, when you're inside one institute and one organization, you all you need is just clinical care and administration within that one organization. But as soon as the patient moves between different organizations, and then the care needs to continue, and you need cross organizational coordination between different actors, then you need data exchange, right? So in a sense, clinical care and administration is intraoperability, whereas like data exchange starts getting into the interoperability space. So here what they argue is that in the clinical care and administration, you need a standard so that within an institute, different applications can coexist, and they can kind of, they can be vendor neutral, and you can just use one app that you want for a particular use case and then like throw it away. And whereas data exchange is more about moving data from one institute to another so that they get continuity of care of that particular patient into this other organization. Now, again, this is also crucial for multiple actors when there are like payers, providers, and there is like these different completely different organizations, right? Like an insurance payer will need the data from a hospital before they can authorize a claim. So this all falls under data exchange. Now, then you finally have longitudinal analysis, which is just population level analytics. You try to understand trends, you try to understand what different cohorts you have in your data, and then you mine this data for valuable insights, or you use this to train your machine learning models. So this is more big data, right? Like this is, you want to do proper analysis and research on the data that you have. So I just want to like quickly jump into the final conclusion of the study, and then come back to a more detailed commentary, right? So what they say is that, okay, we have three really good standards today, and these three kind of seem to work for each of these different domains well. So for example, clinical care and administration, you have openEHR, where within an organization, you are able to build your applications on top of a standard like openEHR. And then when it comes to data exchange, when you want to exchange data between different organizations and actors, you can use something like FHIR, but again, you need to profile your FHIR resources and use it specifically for a particular profile. And for longitudinal analysis and just research, push it to a more flattened format like OMOP. Again, OMOP is in no way uh, simple. It has its different data models, and it models everything on top of existing SQL databases. It doesn't have its own REST API, but OMOP is, in my opinion, much simpler to work with than openEHR or FHIR. And it's much more, if a data analyst who knows SQL looks at OMOP data, they'll just be like, oh, okay. But if they look at OMOP or FHIR, they're like, okay, what is this nested? Like, I don't understand what's going on, right? So that's usually the reaction that I see. But that being said, we also need to tackle a very important part of interoperability, which is terminology and ontologies. So none of these standards that they were mentioned here make sense just on their own. So you still have to use them with terminologies to kind of imply the meaning of what you're talking about. So that's where code systems like SNOMED-CT or LOINC or RxNorm and so many others, they come into the picture. But what they argue here is that the use of terminologies here may also kind of be dependent on what use case you have. So for example, for clinical care and administration, again, this is my personal experience. I'm not commenting on this paper right now. This is just my own experience. When you have to capture data for primary, like the care of record, you tend to capture inventory codes or the codes that you need in order for you to get paid, so that the insurance will pay you. You don't care about detailed SNOMED-CT codes. Sometimes, that's sometimes what the insurer asks for, but most of the times that's not the case. And you just want to like do your regular business, and you don't really care about LOINC codes, or you don't care about SNOMED-CT codes. You just want to get stuff done, and you use your own local code systems. That's completely fine, right? Like when it comes to data exchange, then it makes more sense to start using these more expressive or more globally understood ontologies like SNOMED-CT and LOINC. But then if you didn't capture it to begin with, it becomes this like expensive mapping process for you to just send it out. So people like also capture these codes along with the inventory codes when they are capturing clinical care and administration. Whereas when it comes to longitudinal analysis and like just research, most of the times you're okay with group specific codes. So for example, it again like depends a lot on the kind of research that you're doing. If you're doing some sort of genomic research, for example, they have their own code system for that, right? Like the phenotype project, and they have their own separate code systems for that. And if you're doing analytics of how many people died in what way, ICD-10 codes might suffice. So again, we are not saying that there is no need for one standard, and again the authors are not claiming that, but then it seems like we have this fragmentation of standards. There are these multiple standards that do things differently, and they also encroach on each other's territory in some places. So again, like it may be tempting to ask, like, why not just have one standard, and why can't one standard just do all of this? Because right now you need to map between these different standards to actually get things done, right? Like so, and mapping is again lossy, and again the authors go over this very well, and they talk about what are the problems with mapping, and they talk about the fact that the terminology itself could lose its meaning. um, so yeah, for example, fidelity may be lost when converting from a specific term, for example, fracture of the fourth metatarsal of the left foot, to a more general one, fracture of the fourth metatarsal. But this may just be the nature of what the insurer wants to reimburse your claim, as opposed to what you need to capture in your primary care record. So these are like different domains, right? And again, like information can be lost when you split data. For example, a more rigorous standard like openEHR might have a field to link multiple records together, and FHIR also does this. This may not be the case in OMOP, where you may not have a field to fill a certain thing. Like, for example, what was this drug given against? Like, what diagnosis does this drug tackle? So there may not be a field in OMOP for that, and as a result, you lose the data. So there are these problems, right? Like, there are definitely problems when it comes to mapping between these different standards. And although the community effort has been great here, and people have been recognizing that the tooling to convert between openEHR, OMOP, and FHIR, all of the permutation combinations, is necessary, and they are building all of this. The community is actively doing all of this, but still, it's just the nature of how data transformations work. Like, when you're moving from one domain to another, you tend to lose data and you tend to lose the context, right? But that being said, I just want to take a moment to like reflect on why not use one standard for all, right? Like, let's think about it. Like, why can't we use FHIR for clinical care and administration? Like, I've had a lot of people ask me, can I just store data natively in FHIR, right? And can I have that as my EHR, just a FHIR database? And you can. It's not like nobody's stopping you from doing that. But then when you have to exchange data for a particular use case, like, let's say you have to, like, a very simple example would be there is a standard on top of FHIR called Nafis in Saudi Arabia, which is required for insurance data exchange. And there is another program in India called ABDM. And in the US, you have the US core FHIR profile. Now, all of these have different FHIR profiles. So even if you store your clinical care and administration data as FHIR, you still need to do FHIR to FHIR mapping in order to do that data exchange part of FHIR, right? So in that case, it just becomes an overhead for all of your applications to store data in FHIR and then like come up with extensions yourself. And like, in the end, what's the point? Like, why are you storing it in FHIR? You're better off just, storing it in another format that supports better modeling, better tooling. And openEHR to some extent supports a lot more customizability than FHIR. So I agree with this kind of a paradigm. But then let's consider this other approach where, like, why can't we use openEHR for data exchange? Why should we use FHIR? And this is actually like quite interesting, because this actually is because of history and how things have kind of ended up. So this is the original like Smart on FHIR paper by Josh Mandel. And here he explains, like, again, like there are multiple co-authors, but he's the primary author. He goes into this whole thing where when Smart initially came out, there was this thing called Smart Classic, right? And what they had was they didn't have a proper data model to go off of. They had like HL7 V3, and that didn't really take off. So they had like HL7, it became CCDA, and there's this document kind of a paradigm. But for applications, that didn't really, it makes sense to like just work on documents. Instead, they wanted something much more granular, so they came up with their own standard based on RDF. Right now, I can't find the exact specification online. It's down. It's a really old paper, but still, what happened after this was that since the HL7 version 3 was not gaining traction, HL7 launched this fresh look task force. Okay. And there were two distinct initiatives. So one was by Stan Huff. I think he's currently working at Graphite. And this particular initiative was working on top of openEHR's archetypes. And then there was another task group for resources for health that was designed and published by Graham Greene. So ultimately, they ended up, and again, like this project was called the CIMI initiative, and it's still like you can find it online. The HL7 CIMI initiative, the Clinical Information Modeling Initiative. So it so happened I still have to like exactly dig deeper and like find out what exactly happened here. But the resources for health designed and published by Graham Greene, as we know, and we've also talked with Graham Greene on this, became the de facto FHIR standard. And again, like he had a agreement with HL7 that it would be published under an open license, which is like great going. Definitely the best thing that can be done for the community. Because before this, the HL7 V2 standard was like you have to pay a license to even view the standard. That was bonkers, like in my opinion. But the HL7 FHIR standard became the way it is after this task force, right? Like the task force for the Fresh Look task force. So it could have been, it may have just been the CIMI initiative by Stan Huff. And in that case, you would have had data exchange instead of like FHIR coming into the picture. You might have had openEHR, right? Like there is nothing that is really lacking when it comes to openEHR being used here. But then I actually kind of intuitively like understand this in a certain way, which is the reason why FHIR works so well for these different data exchange paradigms is because people can just pick and choose what they want. They can kind of invent their own standard on top of this standard framework, which happens to be FHIR. And when there is a specific use case and when governments come up with a specific profile, they tend to do this all the time. Like they tend to invent what they want. So I think it is to some extent a people problem, which is like people want to customize their use case and they want to have that sort of customizability, and FHIR enables that. Whereas openEHR is a little bit more rigorous and it tells that, okay, this is the global representation. You can kind of like cut down from the global representation, but then the standard itself doesn't lend itself to like completely move between paradigms and like just in FHIR, the amount of flexibility you get with modeling things is just like a lot more. But that also causes a problem when it comes to modeling things natively on FHIR, right? Like you have smart on FHIR apps that can run apps and that can technically be used for clinical care and administration. But as soon as you have these different use cases, you start doing like FHIR to FHIR mapping, and then you start sending data out in accordance to that specific FHIR profile. So Sidharth from the future here, I know when I talked about FHIR being customizable and then like previously also openEHR being customizable, it might confuse some of you as to which one is the more customizable standard. So openEHR supports the two-level modeling paradigm where you have global datasets published on the CKM as archetypes, and then you can take them and cut them down and then represent these things called templates for your own local use case. So this way, multiple specialties can represent the same concept like medication prescription, but in different levels of detail and with different terminologies and so on. FHIR, on the other hand, has something called profiles, which take an existing FHIR resource and then it adds to that. So you can, enforce certain fields, you can add extensions on top of the field, and you can do a lot more. So while openEHR is good for, creating like, let's say, forms, for rendering forms based on openEHR templates, and you can like, you have these global openEHR archetypes, which you can like use and it's all consistent. FHIR allows you to like just go crazy with a lot more branching out on top of the existing base foundation resources. So the distinction is that for primary clinical capture and usage, you want like these no code or low code tools that can quickly be built. And in that sense, OpenAIR is faster and it's easier to like quickly create something on top of, while still maintaining data consistency, because you always like cut down from these global archetypes. Whereas FHIR, when you profile things, you like add to the profile, like you add to the existing FHIR resource and you come up with your own constraints. And more often than not, let's take for example the observation resource, that is not detailed enough to represent a particular use case like blood pressure or heart rate. So each profile comes up with its own way to represent these specific concepts. So this is what I meant by, like OpenAIR is customizable in its own way, where you can like, there is two-level modeling and you can cut down. But FHIR can basically like do a lot more with the foundation standard, and people can use it across multiple paradigms and like invent their own archetypes on top of existing base resources. Whereas in OpenAIR, you'll have to like create a new archetype, and there's nothing stopping you from coming up with custom archetypes, but more often than not, people tend to use like mostly global international archetypes, and where it doesn't fit their needs, they like invent their own archetypes. So in a sense, like the main difference is OpenAIR defines maximal data sets and cuts, whereas FHIR defines minimal data set and adds. So this is the major distinction. And this to me seems to work well for each of these different domains. So back to the original video. Then comes the question like, okay, fine, forget all of this. There is definitely like the global clinical data capture, and then there is the use case specific data exchange. Maybe it's just a people problem, and like that's why FHIR is good here and OpenAIR is good here. But what about like research and just like analytics on top of data? Why can't we just do like, let's say AQL on top of OpenAIR? Or why can't we, like, there are multiple tools that do SQL on top of FHIR. In fact, there is a whole working group that is doing this. So there is this SQL on FHIR V2 project that talks about how someone can execute SQL on FHIR and what standard should be used. It's very actively maintained. But why are we not doing that directly? Why do we need another format yet again, like something like OMOP, to do this research queries? And my answer to this is just, again, I'm going beyond this paper. I'm not talking about just this paper anymore. This is all my own opinion and my own take. It's not that of the authors. But I think to some extent, both OpenAIR and FHIR, again, OpenAIR is highly nested and it is like super granular, it's super detailed. And somebody just needing to do research may not need that level of detail. And again, AQL is, you need to learn about AQL paths and you need to learn about OpenAIR and the clinical data models of OpenAIR before you can even get started with doing analytics on OpenAIR directly. And I would say the same for FHIR. If you don't understand the FHIR data models, and if you don't understand what profile the data set is in, and if you don't understand how FHIR represents the data structures, like name can be an array and there can be multiple names, and just writing SQL on this kind of a denormalized data is just painful, right? Like the analyst who's doing the research, you don't want them to spend time analyzing nested data structures and like the shenanigans of these standards. Instead, OMOP provides a very simple, clear table structure, which just talks about like, okay, here's a person, the person has these data points. Here is a condition, and these data points are under the condition. The condition links relationally to a person, and all of this can be represented perfectly as SQL tables. Right now, it may not be as high definition as OpenAIR or FHIR, but to some extent, OMOP is kind of what the researcher needs. Like it's in SQL, you can write SQL queries directly on it. You can use the tooling you know and love. And the data models are just like SQL tables. So you can go and you can like explore and just understand everything by just like exploring the schema. And sometimes like the code systems are included in the OMOP package, right? So that makes it even simpler. Like even doing traversals on the code system is kind of simple. You have everything that you need in that one data set to do all the analytics. Whereas if you take something like FHIR or openEHR, it doesn't come built in with a code system like Loink or Snowmet. You still have to like understand these code systems and like go somewhere else and query a terminology server and then do these joins in order to do analytics, right? So I get where like all of these points are coming from and why these are working well for these domains. But at the same time, I just think we may be at the start of a particular development cycle of like health data standards. And this is in no means telling that this is the dogmatic way to do health data, right? Like I think this will change. And as much as I want one single standard for everything that can just be used for everything and all clinical care, data exchange, and longitudinal analysis, today the reality is that there are different constraints, there are different requirements for all of these, and sometimes it's okay mapping data in a lossy way to get all of the functionality that you need. And yeah, like I just thought this paper was pretty cool. And having both of the authors also on our channel before, I thought it'll just be cool to go over what their thoughts are about these different standards. And maybe, I can maybe pull someone else from this paper and discuss these a little bit more. But let me know what you think in the comments below. If you think I should like just invite one of the other authors from maybe OMOP, I'll be happy to like invite them if they are willing to come in on a podcast interview. So thanks again for watching. I hope this was useful in some way, and I'll see you again in the next one.